sequences and series. We have dealt with sequences in our day-to-day life. Sequence is nothing but a form of pattern. For example, if I talk about, say, I deposit, say, ₹100 in bank every month. So initially, the first month, I will be having ₹100 in my bank. The second month, I will be having ₹200 because I have added 100 for this month and 100 was already there in my bank. Then third month, it will be 300. Fourth month, it will be 400 and so on. So it is something which I am doing, a collection of objects which I am having with me is known as a sequence. I can also say population of human beings. Why it's a collection? Because I know that population of human beings increase every year. So as it is increasing, it is also following a pattern. For example, it is 3 billion this year. Another it becomes say 5.5 billion. And so on. So when I'm taking any collection, the collection of my books, and writing down them, it becomes a sequence with or without any specific pattern. It is just, if I say sequence, it is nothing but a collection. I can also say increase in price of petrol. It is also collection. Maybe last month it is 46, then it becomes 48.5, then it becomes 62 and so on. So such collections are known as sequences and we represent it by separating each terms of a sequence by a comma. If I define a certain pattern to it, if it is a sequence and I define a pattern to it, then it becomes a progression. For example, if I say the price of petrol are ₹50 and every year I need to increase the price of petrol by 10 rupees. That means the starting price of petrol is ₹50. Then I'm increasing by ₹10 every year. So it becomes 60 in the second year. It becomes 70 in the third year. It becomes 80 and so on. So it is nothing but it is following a certain pattern. Or if I say it is increasing, it is becoming the square of its number. So for example, the amount of, the cost of a pen is ₹3. And after 4 years it's been doubled. So next year it will be, after 4 years it will be doubled. So it will be 3 square, which is nothing but 9. Another, after 4 years the price of the pen is 9 square. Another it is, so it is forming a certain pattern that after every year the price of a pen is becoming its double. Not double, exactly we are taking the square of the price. Okay. So when they are forming a certain pattern, they are known as progression. And in class 10th, you have already studied one progression which is AM, which is known as arithmetic progression. This progression you have already studied in class 10th. where we say that it's a sequence, and if the common difference is same, then it becomes a arithmetic progression. Before moving on to arithmetic progression, let us talk about the sequence only. For example, a sequence is 2, 3, 7, 12 and so on. If it is moving indefinitely, then such kind of sequence are known as infinite sequence. And each number of the sequence is known as the term. If a sequence has an ending point, for example, my sequence starts with 10, 100, 2000 and so on till say 10,000. Then it has a specific end to it, and such type of sequence are known as finite sequence. So we have studied that there are two types of sequences, infinite sequence and a finite sequence, and each term of a sequence is represented is known as terms of the sequence. Okay, next, sequences are represented by, if I talk about the general form, then sequences are written as A1, A2, A3, A4, so on till AN and so on. This is the general pattern of a sequence, which is then A1, A2, A3, A4, A5, so on till AN and so on, where AN is the number at the nth position. So AN is nothing but the number at the nth position. So whatever is the nth position, maybe it's the 100th position or 50th position, whatever the value I'll be getting at the nth position, that is denoted by AN. And over here, A1 is the first term of the sequence, A2 is the second term of the sequence, A3 is the third term of the sequence, A4 is the fourth term of the sequence, and so on. So this is known as, these are the few things which you need to be aware about sequences. So sequence is a collection of any object with or without any pattern. If a sequence has a definite pattern to it, it's known as the progression. Each number of the sequence is known as the terms of the sequence. There are two types of sequence. First is infinite sequence and other is the finite sequence. Then let's move to the series. What exactly the series is. I have right now told you that A1, A2, A3, so on till AN is the representation of a sequence. So I am saying let A1, A2 till AN be any sequence. Then, if I write an expression, then the expression of the form A1 plus A2 plus A3 so on till AN is known as a series for this sequence. So if I just put a plus sign in any sequence, it becomes a series for that particular sequence. For example, if I take a sequence, say 9, 9 square, 9 cube, so on till 9 to the power n, it is a sequence. Then if I add all these terms of a sequence, 9 plus 9 square plus 9 cube plus so on till 9 to the power n, it becomes a series. Let us do few questions on it, how a question can come. So I need to find out the first 5 terms of a sequence where the sequence is given to me. So the question says, find the first 5 terms of a sequence, find the first 5 terms of the sequence whose nth term is given to you as an is equal to n plus 2. So this is my nth term and I need to find out the first 5 terms. So first term of the sequence will be where the value of n is 1. So it will be 1, 1 plus 2, which is nothing but 3. The first term of the sequence is 3. The second term of the sequence will be 2, 2 plus 2, which is nothing but 2 into 4, which is 8. The third term of the sequence will be where I substitute the value of n to be 3. So it will be 3 plus 2, which will nothing but 15. The fourth term of the sequence will be where I substitute the value of n to be 4. So it will be 4, 4 plus 2, which is 6, into 4 is 24. And the fifth term of the sequence will be 5, 5 plus 2, which is 5 into 7, which is nothing but 35. So these are the first 5 terms of the sequence where the nth term is given to you. Also, they can ask you, find the indicated term in the sequence. So a sequence is given to you. Again, the nth term of the sequence is given to you. Maybe say they have given an is equal to minus 1 to the power n minus 1 n cube, and the indicated term is a9. So this is the nth term of the sequence and I need to find out the 9th term. So 9th term will be a9 is equal to minus 1 to the power, wherever it is n, I'll substitute the value 9 minus 1, 9 whole cube. So it is minus 1 to the power 8, 9 cube. Minus 1 to the power 8 is positive, so it is 9 cube, which is nothing but 243. Okay? Whatever it is, it's not a9 will be 9 cube. Okay. Now, the another question says, a Fibonacci sequence is given to me. A Fibonacci sequence means the sequence in which the first 2 terms remain same. So it has a pattern, but the pattern follows after the first 2 terms. So first Fibonacci sequence says a1 is equal to a2 is equal to 1 and an is equal to an minus 1 plus an minus 2, where n is greater than 2. I need to find an plus 1 whole upon an for n is equal to 1, 2, 3, 4 and 5. So such kind of sequence where the first 2 terms remains the same and n greater than 2 means from the third term onwards it follows this pattern. So I know that A1 is equal to 1, A2 is equal to 1. After second term, the third term will be A3. I'll substitute from here. A3 is equal to A3 minus 1 plus A3 minus 2. So it is nothing but A2 plus A1. I know the value of A2, I know the value of A1. I'll substitute and I'll get A3 is equal to 2. Similarly, from the same formula, I can find out A4. A4 will be A4 minus 1 plus A4 minus 2, which is nothing but A3 plus A2. Now I know the value of A3, I know the value of A2. I'll substitute 2 plus 1, which is nothing but 3. So this is the value of A4. Now let me find out what I need to get the answer of. I need to find out the value of, to find an plus 1 whole upon an for n is equal to 1. I need to find for 2, 3, 4, 5 and so on, but I'll start with an equal to 1. So it becomes a1 plus 1 upon a1, which is nothing but a2 by a1. I know the value of a2, I know the value of a1, so it is nothing but 1. Similarly, I can find out for an plus 1 upon an for n is equal to 2. So I'll substitute, it will be a2 plus 1 upon a2, which is nothing but a3 by a2. I know the value of a3 is this and the value of a2 is 1. So I'll get the resultant to be 2 by 1, which is nothing but 2. So I've done for n is equal to 2, n is equal to 1. Let me find out another one for you. And similarly, you can find out for 4 and 5. So A for n is equal to 3, an plus 1 upon an becomes a3 plus 1 upon a3, which is nothing but a4 by a5. I know the value of a4 is nothing but 3, sorry, a3, I'm so sorry, a4 is nothing but 3, a3 is nothing but 2, so this is the value. So similarly, I can also find a5 by the same formula and a6, and substituting over here, I can solve for n is equal to 4 and for n is equal to 5. So such sequence in which the first two terms remains the same, and from second term onwards, from the third term onwards, it follows a certain pattern. This is known as the Fibonacci sequence and Fibonacci series. Okay. Now this is the first introduction of your sequences and series, where you studied sequences, series, how to find questions based on it. Let us move to the first type of progression, which we have already studied in class 10, that is arithmetic progression. So arithmetic progression is nothing but a sequence in which the difference between two terms is same. So what is arithmetic progression? It is a sequence in which difference between two terms